Hey, I'm Julie Lerman, and this is part 2 of my video series on Entity Framework Core, working on the bucket list. I just got back from skiing out in my woods, and I came home and my house is empty. My husband's out, so I thought, ooh, good time to record another video. So the first video in this series was focused on Entity Framework Core query performance. This time, I'm going to talk about some more performance with respect to something called a new feature called compiled models, which makes it so that you can start up your applications more quickly. This is a feature that benefits you if you have big models. Now, I usually try to guide people to have smaller models, and I do a lot of domain-driven design, and that thinking really has my head around having smaller models and solving smaller problems isolating the different problems. But that is not where everybody's at. A lot of people have large models, and when you have a large model and you start up your application, and not just the application startup, but it's actually the first time that Entity Framework has to use your model, it has a lot of work to do. A lot of work to do to figure out what the model should look like, reading your classes, reading the DB context, and spinning up the model in memory so that Entity Framework knows what to do when you are creating queries or updating data, so when it has to interact with a database. So the first time your application instance does that, the first time your application instance needs to use your DB context in an application, and it's actually not when you're instantiating the application or instantiating the DB context. It's when it's that first time that it actually has to do something between that context and the database, whether it's a query that you're executing or calling save changes. So this is just a little overview of what's in the series. So I already dealt with the query performance, and now I'm going to focus on startup performance. And the feature that allows us to do that is called compiled models. Now, we actually had pre-compiled models in EF6. I can't remember if it was in EF5, but I know that it's in EF6. But the way it works now is very different. So when we got EF Core, like the first version of EF Core, there was no way to pre-compile the models to try to make startup performance better. So finally, all these versions later, and it's not really 6 versions, we had EF Core, which is the first, EF Core 2 and 3 and 4, and now 6. So that's 5 versions. With all of those versions, we didn't have it before, but we have it now. And they completely rethought how that works. So it doesn't, the way it works under the covers and the way that we implement it in EF Core 6 is very different from EF6. So if you've used them before in EF6, you still might want to pay attention. What I want to start with is give you an idea of the kind of performance improvement you can see with pre-compiled models. So what I want to lean on to begin with is this really good demo that Arthur Vickers did, and Arthur's like the lead engineer on the Entity Framework team, and he's been working on the Entity Framework team for a really long time. So he created this demo, which he showed on one of the EF Core community stand-ups. Those are all on YouTube. And it was a really complex model. So I'm not going to demo this, but I want to explain this. His model has 449 different entity types, almost 6,500 properties, and 720 relationships. It is a large and complex model. He's got the demo on GitHub, and I ran the demo on my own computer, and there's a before and after. So both the before and after are using Entity Framework Core 6 and .NET 6. So the difference is one is just creating the model on the fly the way Entity Framework normally does, or EF Core normally does, and the other is taking advantage of the precompiled models feature. So here is the average startup time, or the mean startup time. And also, if you watch the first one of these videos, I talked about using benchmark.net. So I used that in the previous demo also to do some benchmarking. And Arthur is still using benchmark.net to do this comparison. So the startup time, the first query, the time to get to the very first query was 1.8 seconds. And when he's using the compiled models, the compiled model feature, it was down to about 158 milliseconds. So again, this was me downloading his demo and running it on my computer. So that is really significant. It's more than 10 times faster to do that. So I'm going to show you Arthur's demo, but what I'm going to do is use my own much simpler demo so you can see the forest for the trees, or see the trees for the forest, what I'm doing and what the impact is beyond just the difference in speed. So before we look at the code, let me give you an idea of what it is you need to do to actually implement this feature. It's actually not a lot of work at all. 2 steps, in fact. If you're using the command line interface, then you can create a compiled model with just a command, one of the migrations commands. So it's .NET EF DB context and then optimize. So optimize is a new method for DB context. And if you're using PowerShell in Visual Studio, it's optimize dash DB context. What this does is it creates a folder with a whole bunch of optimized model files. I'll show you what these look like. And then you need to just let the DB context know, when you're spinning up this DB context, don't waste your time going to read through all of the classes and all of the configurations and figure all of that out, right? Because it looks at like what DB sets you have and what other entities you've referenced in the DB context, goes and reads all of those classes that those reference. From those classes, it uses its defaults or its convention to make assumptions about what the data model looks like, and the data model as it maps to the database, so what the database schema looks like. Then it reads all of the configurations that you've added in the DB context, or if you're using data annotations. I really never use them, so I'm always focused on the APIs inside of the DB context, the Fluent APIs. So it does all of that work. That's only part of why there's so much effort involved and why that first execution, that first use of the DB context takes so much time to get to. Once it's done all that work, it leaves that model that it's figured out in memory for the application runtime. So it's really just that first time. And so once you've created these optimized model files by just saying optimize, then you just need to let the DB context know, use those files, use the optimized files, don't go through your whole normal expensive process. Okay, and so we have a new use model method in the EF Core API. So you just do that in on configuring. So I'll show this to you. Before I go through actually doing optimize and showing you how these models look, like what optimize creates and then how DB context is using them, I do want to give you a look at Arthur's demo. But we're not going to do that work to his demo because it's so big and it'll be really overwhelming. So what I have here is what his demo looks like after you've done the optimize. So before even optimizing, he's starting with all of these classes. They just have these funny names because they're just for testing and demo. So there's all of these classes, and the classes have, again, like lots of properties and lots of relationships between them. And let's see what his DB context looks like, if I can even find it, which is, right, this is kind of why when I actually run the demo and do the optimization, it's just going to be easier to do it with a tiny little application that doesn't have a lot of stuff to go through. Where I can't even find the DB context. I know I can just search, but I just want to see it. Where's the context? Maybe it's up in here. Oh, duh, there it is. Okay, so you can see in here also he's defined all these different relationships, and there's just a lot going on. So that's why I'm not going to run this demo, but you can download his demo and go through the steps if you want to. So I'm just going to close this, and I'll open up my little demo. So the big difference now is his demo is really using a complex model, the kind of model that's really going to benefit from compiled models, pre-compiled models. My demo is easier to see and understand, but it won't give you the performance difference, right? Because I'm just have a tiny little model. You're not going to see any performance difference. So we're not looking at performance now. Here, I just want you to see what it looks like to implement. So this should be empty. Okay. As a matter of fact, let me just delete that. That shouldn't even be there. There. Goodbye. So I have a tiny little model. I have 2 little domain models, like just person here, and person, it's person and addresses. So I have a person class. It's very simple. It's got an ID, first name, last name, and it has a collection of addresses. And here's address with just a handful of properties. I even have a little enum that I'm using. But overall, it's pretty simple. This will not benefit at all from pre-compilation. But again, I just want you to see what it looks like. Inside the context, I'm really not doing anything at all, nothing special. So what I'll do then is, since I'm in Visual Studio Code, I'll use the CLI. So it's .NET EF DB context optimize. And we'll see what it creates. Also, it's nice having only 2 classes because it'll run this very quickly. So notice that compiled models folder got recreated, right? So here is that. What's inside of it? There are 4 things. For each of my classes, I have an entity type. So there's address entity type and person entity type. And then there's 2 files to take care of the context. So let's first look at the person entity type. What the compilation, the optimized process has done was created a class that has all the information that EF Core needs in order to understand where person, what person looks like in the data model. So it's just one place with everything already very explicitly laid out about every property, about every mapping, and even some annotations. There's not much. There's just one for table name. And that's it. So what that means is at runtime, Entity Framework doesn't have to go and look at the DB context to discover that person is part of the model, then go look at the person, figure out what its what the entity should look like in terms of the data model, and then go back and look in the DB context to read through any special configurations that we've mapped with the Fluent API, right? Everything is just right there and streamlined. All the work has been done. So address entity, same thing. One interesting thing about this one is the information that the context needs about the relationship between address and person is in here. Because it's the dependent, it makes more sense. So scrolling down. So here's information about the primary key. By the way, there was one of those in the person entity class as well. And also here, it's explicitly laying out everything it needs to know about the foreign key and the relationship between it and person. So all of that information is there. Entity Framework doesn't have to waste its time figuring it out. So what are these other two classes related to the context? There's the model builder and there's the model itself. Okay, so the model is what we're going to tell the DB context to use. So, and the model follows a specific pattern and it implements this runtime model, right? So it knows which methods are going to be called, and then this just gives it some logic to follow in those methods. So it's model builder that's more interesting. Model builder is what is aware of the various entity types and foreign keys and annotations that Optimize discovered. So it's just going to set all this stuff up here, right? So here's the entity type. Go ahead and create it. Go ahead and create the person, and then we're going to pass all of those things into the model builder. So once all of this stuff exists, right, I haven't done any work here, really. I just wrote, .NET EFDB context optimize, right? So all of this stuff gets created for you. Now I just go back into the people context, and I have to tell the options builder to use this new model. And honestly, it's just use model and then the people context model. And I just need to get the using statement in there. No, for this one, control period. There we go, using compiled models. So get the benefit of IntelliSense now. Instance, right? So you don't use the people context model. We're going to use the instance. And you saw that there was the instance method, so it will run through and just do all that work. And that's it. So it just did two things. I optimized the model, and then I told the DB context to use the precompiled stuff instead of going through all of its usual effort of doing that. So I'm going to put a couple of breakpoints in here and then just run this so you can see it hitting the actual precompiled code instead of the regular. So I'll go into compiled models. I'll just open up address type and just stick a breakpoint in here somewhere. I just kind of want to do it towards the top. Okay, so I got a breakpoint in there. And then in the model builder, again, kind of randomly, I just want you to see that it's actually doing those things. And I'm not running any special code. So I'm just going to hit F5 to debug. And then you'll see it hit the breakpoints in the compiled model classes. So there's the first one. And keep running. And there's the breakpoint inside of the model builder. And that's it, right? So again, two different demos. The big demo, Arthur's demo, is to, if you really want to take a look at the performance difference with a really, really big model. And my little bitty demo is just so that you can take a look at, easily see and consume what it looks like to implement the optimize feature and get the models and see it running without having a million different classes to look at. So that is it. And let's see how long has this been so far? I don't know. Why doesn't it tell me? Well, I'll just, say, okay, that's enough for one little video. Nothing else to see here. So what I'm going to do is, just as a reminder, this was one big talk. I decided to break up into little videos so that I could talk as much as I wanted to about each thing. So what I'm going to do now is scroll back up to the little overview so you can see what else to expect in here. So I've talked about the startup performance and the query performance. The next video will be about an easier way to deploy migrations. It's really cool, really fun. And I'll also be talking in other parts of this, other videos, about the new temporal table support. I'll show you how you can do mappings, bulk mappings, not only for conventions, but also for value conversions. And, we'll take a look at some other things. So, I'm just having fun with this. This is all based on a talk I've done for a couple of conferences, and I've never really had very much time, an hour or 45 minutes even to do the talk. So I can't dig in and explain all the things that I really want to. So that's why I'm doing this series. Now, close your eyes for a second. I'm just going to scroll all the way back to the bottom so you can just see the links page. And all of my demos from this talk are this video, right? And the whole series are on my GitHub account, and the name of the repository is called EF Course 6 Demos. And these are just other links of important resources, I think, that will help. And if you're waiting for my Pluralsight course, I should say, I kind of had Pluralsight in my mind. I don't know if you can see this. Oh, yeah. I happen to be drinking my drink out of that, and it's just coincidence. I'm wearing, let's see, does it show my Pluralsight little hoodie from an author summit from, what year was this? 2018. I haven't traveled in a long time. So if you're looking for the next Pluralsight course, I am working now on the next EF Course 6 course. So the previous ones were called Entity Framework Core Getting Started. This one will be called EF Course 6 Fundamentals. So it'll be just like my Getting Started courses, but a little bit more information. And I'm working on that now. It's early December right now. I think it's going to take a couple of months, so hopefully you'll see that by February. And in the meantime, I'm doing these just because they're fun and really easy to do. The Pluralsight course is a little bit more work. Anyway, thanks so much for watching these. Watch for the rest of the little videos in this series on my YouTube channel. Bye.